So we're going to talk about linear equations, functions, zeros, and applications. So there are a lot of word problems in this section. We're only going to go over a few of them, and I've kind of abbreviated them a little bit just for save some time in board work. So a linear equation in one variable is an equation that can be expressed in the form mx plus b equals 0, where m and b are real numbers and m does not equal 0. So this is kind of getting back to solving equations. And so what we're going to do is remember that there's this idea of addition and multiplication when we're dealing with these. So here I need to isolate my x. So what I'm going to do here is I'm going to add 1 to both sides. So I end up with 3/4 x equals, well, 7/5 plus 1. I have to convert that 1 to be a fraction. It's 5/5. So that gives me 12/5. Okay, so this gives me 5/5 plus 7/5. Now, I need to get rid of this 3/4. And so what I'm going to do is I'm going to multiply by its reciprocal. So I'm going to multiply by 4/3. And that will give me x over here. And then I'm going to go ahead and I'm going to do a little canceling here. So this is 4, just to make it a little easier. 4 times 4 is 16. 5 times 1 is 5. So x is 16/5. On this one, we have a little bit more. We have some distribution problems. And so what we're going to do is we're going to distribute first. So 2 times 5 is 10. 2 times -3 is -6x equals 8 minus -3 times x is -3x minus 6. And so I'm going to go ahead and simplify each side just a little bit more. So 10 minus 6x equals, here I have 2 minus 3x. Now, a lot of times I will take my smallest coefficient on my variable and move it first. So I'm actually going to add 6x over. And so I have 10 equals 2 plus 3x. And I'm going to go ahead and I'm going to subtract off 2 here. That gives me 8 equals 3x. And I'm going to divide by 3. X equals 8/3. Right? Now, there are some special cases where you might end up with the same x on both sides or the same value. So I might have something like this. 7 minus 4x equals 17 minus 4x. And here the 4x's are going to cancel out, and 7 equals 17. Well, that never is true, right? And so this is a case where there is not a value of x that makes that a true statement. So now we're going to look at motion. So motion is distance equals rate times time. And so our example 7 is this idea about airplanes. And one airplane travels at 290 miles per hour, and the second airplane travels at 517 miles per hour. So airplane leaves one hour prior to airplane 2 on the same flight path. So they're going to be traveling in the same direction at their cruising speed. How long will it take airplane 2 to overtake airplane 1? So if I was to look here, I'm going to put a d sub 1 here, just to indicate that that's distance 1 of airplane 1. Okay, so I'm going to have 290 times time. D2 is going to equal 517 t. Okay, and so we want to make sure that we can understand that each of these is flying at that amount of time. Now, one of the things is this would be T1 and this would be T2. Well, how is T2 related to T1? How is T1 related to T2? Well, it's 1 more hour, right? And so we could substitute here, and then my time here, I could rewrite this to be this, 290 t plus 1 for that extra hour, and this is going to be 517 times t. Okay, so I'm going to add 1 hour because it's flying for 1 hour more. Now, my distances have to be the same for it to overtake, so I'm going to set these equal to each other. 290 times t plus 1 equals 517t. All right, and I'm going to go ahead and I'm going to distribute this out. And then I'm going to subtract off 290t from both sides. Okay. And so I'm going to end up with 290 equals, and here, if I, this is going to give me 227t. All right. So now, when I look at that, I'm going to go ahead and divide by 227. And t is going to equal 1 hour, about 1 hour, 1.28 time. So airplane 2 is going to be traveling for an hour and 28ths of an hour. Okay, that's not, remember, that's not minutes, that's just 1.28 hours. All right, simple interest. So here's our simple interest formula. Now, when we're doing these problems, we want to make sure we kind of understand the proper approach to these. So the first thing is understanding the question. So sometimes that will involve kind of familiarizing yourself with maybe how interest works, how the motion formula works, that kind of stuff, giving an estimate or kind of a guess at it. So you want to make sure that you familiarize yourselves, translate anything here like into equations, kind of set up your plan of attack, so to speak, so that you're going to plan it out. You're going to so step 1 is understand the question. Step 2 is going to be plan it out. Step 3 is to carry out your plan. Step 4 is to check your answer. Make sure your answer makes sense. You should be able to plug it back in and check it. And then step 5 may be to restate it into a familiar form. So like here, I probably should have put hours, right? Okay, so here's our next example. It says 2 simple interest loans totaling $28,000, one at 5% and the other at 3%. After 1 year, $1,040 is owed in interest. How much was each loan? Okay, so I don't know exactly how much each loan was. So for instance, I have my first loan. So I have a loan that's tallied at X dollars, right? And so my other loan has to be $28,000 minus X. Because if I know the first loan amount, okay, let's say that's at 5%, so this is my 5% value here. I know that the other loan has to be that much minus that. And so now I can set up my formula. So I have 0.05x plus 0.03, 28,000, one more zero, minus x equals, now my interest here, okay, is going to be 1,040. Notice here I did not put in a t here. That's okay. I actually did. The t is 1 year. So we have 1 year. So this is actually, technically, it's 0.05, okay, times my time, which is 1, which gives me 0.05. X is my principal, okay? So now I can go ahead and distribute my 0.03, so 0.05x plus 0.03 times 28,000. This is 840 minus 0.03x equals 1,080. So now I'm going to simplify 0.02x plus 840 equals 1040. I'm going to subtract off my 840. 0.02x equals 200. Divide by 0.02. And I'm going to get my total here is going to be x equals 10,000 here. And then, so loan 1, loan at 5% is equal to $10,000. Okay, loan at 3% is then going to be $18,000 because they have to add up to $28,000. So the zeros of the function is when the output equals 0. It's where the graph crosses the x-axis. It's where if I plug in a value, I get 0. Very important to understand that we have zeros of functions and where they're at.